Hello everyone. In this video, I'll be explaining the problem length of longest subarray with at most k frequency. So you are given an integer array nums of an integer k. The frequency of an element x is the number of times it occurs in an array. Okay. The array is called good if the frequency of each element in the array is less than or equal to k. Return the length of the longest good subarray of nums. A subarray is contiguous non-empty sequence of elements within an array. Okay, so let's understand the problem statement and yeah, length of longest subarray with at most k frequency. So in the problem statement, what they've said is they'll give an array A, okay, whose length is n, and they'll give one integer k. Okay, now you need to choose subarray. Okay, um, we need to choose, not just subarray, we need to choose longest subarray. We need to choose longest subarray such that the frequency of each element in that subarray should be at max k. Okay, it can be lesser than k, like frequency of element, let me call it as a of I. Okay, in that subarray should be lesser than equals to k. It shouldn't be greater than k. If it is greater than k, frequency of that element a of I is greater than k, then that is not a good subarray. So we need to find the longest subarray. Let's take some examples and understand. We have 1 2 3 1 2 3, and then we have 1 2, and your k is equals to 2. So first of all, how many subarrays you can have in this? You can have n square subarrays, right? How? So you will start with 1. This is one subarray. You will start with 1 2, then 1 3, then 1 4, 1 5. Okay. The index I'm saying. These are the subarrays. Like you will be choosing just one, then 1 comma 2, then 1 comma 2 comma 3, then 1 comma 2 comma 3 comma 1 1. So you will be doing you know this way, and then like starting from 1, you will take every element, and that is one of the subarray. And since let's say you have taken one of the subarray as this 1 2 3 1 2 3, and in this subarray if you see the frequency of 1 is it has occurred 2 times. Okay, 2 which is lesser than equals to k. Frequency of 2 is, again there are two elements, it is 2 lesser than equals to k. Frequency of 3 is there are two elements lesser than equals to k. So this is a valid subarray, you can say valid, or we can say good subarray, and its length is 6. Similarly, what you can do, you can choose from starting from 2, this index, then this is one of the subarray, this is one of the subarray, this is one of the subarray. So since in the question n is like 10 power 5, if you try to implement this solution using two for loops, okay, it is going to give you n square, which is this will give TLA. So we'll have to look into some other way of solving this. So we have one, two, three. We have one, two, three. We have one and two. So what we'll try to do is we will try to um, take the elements. Okay, we'll try to take this element and put in an map. In map we are putting in map if you see one we don't have, so one element has got a frequency of one, then and which is within the range since case 2, so the frequency of that element is 1, so it's good. Now we'll move ahead and we'll say 2 is not there, so we'll insert and its frequency is 1. Then we'll move ahead, we'll see 3. Since you are moving from left to right and um, since you're moving from left to right and each element frequency you're checking into map, so in map whatever element will be there, right, so its frequency is always lesser than equals to k because you have already doing a checking operation, so 3 is not there, you're inserting. Now you went to 1. Since you have found one that is already present in the array and its frequency is 1 which is lesser than k, so you can increase its frequency, and by increasing its frequency um, again it is lesser than or equals to k, so this is valid. So you can think of this 4 elements is a valid, so you can uh, put answer as 4, then you'll move ahead, and 2 is already present in the array and its frequency is 1 which is lesser than k, so you can increase. After increasing also I mean whatever element will have in the map, so its frequency is always lesser than equals to k, so you'll have to increase its frequency. When you are increasing, now you can check its frequency, it is lesser than equals to k, so it is good. So again it's like you can take these elements, so it will be length 5, then you'll move ahead and now uh, 3 is already present, you'll increase its frequency which is 2, now again it is lesser than equals to k, that is also fine, so you can take these 6 elements, so I've got 6 now. Now when you try to take 1, what will happen is the frequency of array you're going to increase to 3, and now you'll check against the required frequency, which is like the frequency of 1, frequency of 1 is greater than k, which is 3 is greater than 2, so this is not valid. So what we have to do is when you have included these elements, so somewhere you'll have to remove now one from the backside in order to make sure we are taking the longest subarray. So one more pointer you will initialize. Okay, you'll initialize from here, and what you'll do is now this pointer will reduce its frequency. So since this pointer has got element is 1, so you will reduce its frequency. Okay, until how much? Until this the current element's frequency is lesser than equals to k, because this is the element wherein the issue has been caused, right? This element, so you'll have to make sure somewhere you'll have to move a pointer from left to right, uh, making sure that the present element whatever is there, its frequency has to be within the range, so you'll move now pointer ahead. Okay, so since the frequency of 1 is balanced now, so now if you check, the length is only this much, the array will look like something this way, it will look like 2 3. My bad, charge has gone. So I think you guys understand, it's like two pointer approach. Okay. So it's like now your element is only this thing 231 and 231. So its frequency, all the elements frequency is 2, and which is less than equals to k, and still your length of the array is 6 only. Now again you'll move this pointer ahead, and now frequency will make sure it will be 3. But since frequency is greater than k, so you will make sure the left hand side pointer, you will move ahead. And when you're moving ahead, this element you'll have to remove. So again, you'll make frequency of 2 as 3. I mean, frequency of 2, whichever it was 3, you'll make it as 2. So it will begin within the bound. So this will be your valid array. And if you say 3, 1, 2, 3, 1, 2, okay. So all the element has frequency 2, which is lesser than equals to k, and it's a valid one. And when this pointer moves ahead, uh, I mean, it moves to the nth element of the array, then we need to stop. So I think you guys have understood it's a basically two pointer approach, and it's easy one. So first thing first, what we'll have to do, we'll take n as nums dot size. Now we'll take left pointer, which is initially 0, right pointer is 0. We'll run a loop while right pointer is less than n. Okay. So this is right pointer and this is left pointer. And we'll take answer. Initially let us call it as 0. And we'll take one unordered map. It stores the frequency of the element. So let's call frequency only. It will be good. So when you are entering into the loop, you'll have to make sure the frequency of rth element is increased. Okay. Now you'll have to check while the frequency of this nums of r is greater than k, meaning you are entering, I mean, you are increasing its frequency uh, of nums of r in the frequency map. So you have got a frequency. So if that frequency is now greater than k, so you will have to make sure from the left pointer you will move ahead in such a way that frequency is within the range. So you will do frequency of nums of left minus minus and left pointer you're going to increase. Okay. Now when this condition will hold good, when it's a valid good subarray, so this condition is going to hold good. Now your answer will be max of answer comma r minus l plus 1. This is length of the good subarray. Okay, you can think of this way. Your r is here and your left is here. So left is as 0, r is at 5. So 5 minus 0 is 5, but the actual length is 6, right? So that's why plus 1. And then you'll have to do r plus plus. At the end, you'll have to return the answer. So it is running fine. Let's try to submit. So yeah, it got accepted. So now if you try to analyze the time complexity, since right is moving from 0 to n and left is also moving from 0 to n, so it will be maximum of 2 passes, just 2n, okay, which is linear. And space complexity is like it is storing the frequency of all the elements. So at max, if all the elements are unique, so it's O of n. So space complexity is also linear. So both time and space complexity is linear, which is way I mean better than the n square solution. So yeah, thank you guys for watching the video.